today's lesson 1.2, one-to-one functions. So we've already discussed the definition of a function when each input has at most one output. So in other words, the members of the domain cannot repeat, but the members of the range may repeat. In a one-to-one function, sometimes denoted with a 1 like shown here, neither are allowed to repeat. So let's take a look at exercise 1. Consider two simple functions given by the equations. We have f of x equals 2x and g of x equals x squared. I'm going to start reminding you about annotating. All right, we are something that we're going to be doing for the rest of our lives. So it says f of x equals 2x and g of x equals x squared. So map the domain of -2, 0, and 2. So in other words, this is the domain, this is the input. Reminding ourselves what the word domain means. It means the x values. Fill in the range. So the range are going to be the outputs or the y values. And show the mapping arrows. So this is f of x. So that means what we're using is the f of x is equal to 2x over here. So 2 times -2 is -4. 2 times 0 is 0. And 2 times +2 is +4. All right, so now we're going to take a look at the next one, which is g of x. And g of x is equal to x squared. So be careful here, because -2 squared, just going to remind you, -2 squared is equal to -2 times -2, which is +4. 0 squared is 0, and 2 squared is also +4. So if we take a look at these two examples, we can see how in A with f of x, we can determine that this is a function. So f of x is a function because that's the first thing we need to determine. Because it's not called one-to-one, it's called a one-to-one function. So f of x is a function, that's the first criteria, and it is also one-to-one. Because none of our x values repeat and none of our y values repeat. Again, if it's easier to do this, -2, -4, 0, 0, and +2, +4. So all of our x values are unique and all of our y values are unique. So let's take a look over here now, and we can see that we have a little bit of a different situation. Here we have -2, +4. We have 0, 0, and we have +2, +4. So in this case, when I take a look at this, I can say g of x is most definitely a function because those x values do not repeat, all right? But it is not one-to-one. All right, so taking a look a little bit down below here, it gives you the definition of a one-to-one function. A function f of x is called one-to-one if the x's, so x1 does not equal x2, and it also implies that f of x1 is not equal to f of x2. Don't flip out by this. This is just saying that the y's cannot be the same. The x's cannot be the same, the y's cannot be the same. So if you take a look at this, I know I can highlight here somehow. If I just remember how to do this. This one? No, not that one. I know I can highlight. Oh well, I won't highlight. How about we just do this? In other words, every input has to have a unique output. All right? So every person must have their own birthday. They can't share it with anyone else. If you think back to the analogy that we used in the last lesson. So if you need to pause at this point, do that, and then I'll meet you at exercise 2. Of the 4 tables below, one represents a relationship where y is a one-to-one function of x. Determine which it is and explain why the others are not. Explain why the others are not. All right, so 1 represents a one-to-one function. So let's see which one that we think it might be. So if we take a look here, we have to first determine if it's a function. So when I look at exercise number 1, choice number 1, I can see how the 4's repeat here and then the 9's repeat here. So this is not a function. So therefore, it can't be one-to-one if it doesn't even meet the criteria that it's a function. All right, the second one says -1, 2, 0, 1. This one's a function, and then I look at my y's and I see in my y's that I'm repeating here. So this one is a function, but not one-to-one. All right, how about exercise 3? Number 3. 1, 2, 3, 4, 2, 4, 8, 16. Ding, 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 ding. I think we have a winner here. So this one is a one-to-one function because none of the x's repeats and none of the y's repeat. Why don't you write that down underneath there? All right? So none of the x's or y's repeat. So what's the problem with number 4? Oh, it's not a function. Right there, you see it. As soon as your first criteria, this one is not a function. So it can't be a one-to-one function. So it says to explain why the others are not. So this one is not to one-to-one because it's simply not a function. So it can't be a one-to-one function. Not a function, so let's say so it cannot be a one-to-one function. And I'm going to put here the x values repeat. That's why it's not a function. I'm trying to hit all my bases here. When it says to explain something, you better explain it to death. All right, so let's take this one. It is a function, but it's not to one-to-one. And let's put here because the y values repeat. Okay, we don't have to explain this one because this one, number 3, is a function. And this one's not a function. And why don't we say because the x values repeat. Very important, something we're going to be stressing over and over this year is how when it says to explain, you explain. You need becauses in there. You need to explain using the definitions of why what they're asking for. If they're asking why something is a function, you are using the definition of a function to explain why or why not it is a function. All right, same thing that goes for the one-to-one. All right, so write down what you need to before we turn the page. In exercise number 3, consider the following 4 graphs which show a relationship between the variables y and x. All right, A says, circle the two graphs above that are functions. Explain how you know they are functions. So let's look across. Functions means the vertical line test. When you're looking at a graph, that's the easiest way to determine that. So again, I'm just going to give us a vertical line right here so we can just use it. And we can say how number 1 is definitely a function because it only hits in one spot. Number 2, nope, definitely not a function. Number 3, this beautiful circle is not a function. And then this linear function at the end here is also a function. I said it was a linear function. All right, so I gave it away. So circle the two graphs that are functions. So here's one, and here's the other. These two are functions. And this is explain how you know. So you can say we used the vertical line test to determine they are functions. So to determine that each input has a unique output. Could you also say to determine that the inputs don't repeat? Of course you could. That's fine too. We've used a couple of different ways to determine or explain what a function is. Like I said, not a big fan of saying the vertical line test and stopping there, but if that's what you remember, that's what you're going to write down. So of the two graphs you circled, which is a one-to-one? Which is one-to-one? Explain how you can tell from the graph. So explain, they want to know which one is one-to-one, and that's the horizontal line test. We talked about the vertical line test just before. So now what I'm going to do is I'm going to give us a horizontal line and determine which one is going to be a one-to-one function, because the first thing, determine if it's a function. So in other words, I'm not considering this one and I'm not considering this one. No reason to test for horizontal line because it failed the vertical line test. So if I slide this up and down, see how it only hits in one spot? So that horizontal line test obviously works very nicely here when the smartboard works properly. All right, so it works here. So I know that this is not a one-to-one function because it hits in more than one spot. All right, but now if we consider the linear over here, we can see how this only hits that linear function in one spot. So that's why this one is a one-to-one function and the number 1 is not. So this one is a one-to-one. The number 1 is not. And it says explain how you can tell from the graph. You know, again, lots of different ways to do this. You can say, well, first I determined that 4 was a function using the vertical line test. Then I applied the horizontal line test and it crossed only once as I moved it. Not the best explanation, but basically that's what we did. All right, we didn't, if they ever asked us to explain, I prefer you using more of inputs and outputs. But if you use the vertical line test and the horizontal line test, it's really okay to write down, but write down how you used it. right? So to determine if a relation is a one-to-one function, number one, first determine, is it a function? So no x values repeating, or you can use the vertical line test. Two, determine if it's one-to-one, no y values repeating, or using the horizontal line test. Moving on to exercise 4. Which of these following represents a graph of a one-to-one function? This is simple. This is just a multiple choice question, no explanation needed. So this is where that vertical line and horizontal line test are perfect. So why don't you take a second and figure out which one is a one-to-one function? Well, hopefully you realized it's this one right here, because vertical line test, this one's not even a function. This one does not pass the horizontal line test, so it's not a one-to-one function. And this one is the same thing, won't pass the horizontal line test, so it's not a one-to-one function, although it is a function. Exercise 5. The distance that a number x lies from the number 5 on a one-dimensional number line is given by the function d of x equals absolute x minus 5. That, by the way, is the definition of absolute value. All right, how far a point is from 0 on the number line. All right, it says show by example that d of x is not a one-to-one function. So there's a couple of things that you can do here. It just shows by example. You can put it in your calculator and sketch it. You can write down a table. There's so many different ways. It's not being specific. So I think what I would choose to do is maybe make a table. X, and instead of writing y, I'm going to write d of x, because that's my y here. It's the same thing as y. All right, and because 5 is going to be my turning point, and I can see that by looking at it on the table. Put this in your calculator, by the way. 4, 3, 6, 7. So when I put 5 in here, I get 5 minus 5. So I get 5 minus 5, absolute value, which is equal to 0. Here I get 4 minus 5, absolute value. Remember, 4 minus 5 is negative 1. Absolute value is positive 1. Absolute value 3 minus 5 is negative 2. Absolute value is positive 2. Because remember, absolute value is the distance. There are no negative distances. All right, same thing with 6 now. Absolute value of 6 minus 5 is positive 1. And 7 minus 5 is positive 2. So as I can see here, my x values are not repeating. So that's kind of showing me that this is a function. But because the y values are repeating here, this is showing me that it is not one-to-one. So show by example that it's not one-to-one, but we're going to say, so d of x is not a one-to-one function because there are multiple, I love that word, multiple y values for a given x value. Okay, 19.06. All right, we're getting under 20 minutes here. So there you go, 1.2 done. So what we're going to do now is move on to our independent practice during class. You're going to use your people to help you figure out the answers to these things. But remember, please, these workbooks are yours. I want you writing in them. I want you highlighting in them. I want you using colored pencils in them. Whatever you can do to make yourself remember things by example, by writing things down. Like as you see on this smartboard, I use lots of different colors. You should be doing the same thing in your notebooks or in your workbooks. All right, colors make things interesting and fun and easier to remember. All right, so please be Be creative with your workbooks. Use different colors. I have colored pencils in the classroom. You are always welcome to borrow them. All right, so until next time, make good choices. Bye.